For the very abstract way that graphs are most commonly talked about, at least in the mathematical context, in the pure math, the combinatorial sense, it makes sense to not bother attaching any sort of value to the edges. It's just a connection that we can use and abuse to find certain properties, to define certain relationships, to talk about how these things can push apart or come together. But in the real world, in terms of applications, it might not make sense to be so, well, abstract about it. It might make more sense to be specific about the value of that connection. For example, if we're talking about something like commercial travel routes, we're talking about flying from New York out to San Diego, you might want to think to yourself about how much that flight might cost, how far of a flight that might be, how much fuel that flight might use, how long you'd have to spend in airports as part of that travel. So it wouldn't really make sense to say that that connection between New York and San Diego is the same as the connection between New York and Boston. And that's where we'd introduce the idea of a weighted graph, a graph where the edges have a specific value associated to them, a cost or a benefit, but just some weight attached to them that may make you want to use one over another for whatever reason, for whatever model they might connect. So if we want to talk about something like average costs, we could make a graph like so that talks about the costs of flying from Seattle to Dallas or Atlanta or Chicago or LA or any of those other potential connections in there to specifically look at how those things might come together, how you might plan travel around those locations. Because going directly from Seattle to Atlanta would cost you $140, whereas going from Seattle to Atlanta through Dallas would end up costing you $205. It's a matter of what you might be looking at there, what things you might want to talk about, what your cost-benefit analysis might be, but the point here is that those two connections might have some very different value associated to them in terms of what you're trying to do, and this is why we have this construction here. This is why we talk about weighted graphs, where, yeah, it's just one thing instead of none. It's more specificity than just an abstract object, but obviously there are more things that you have to think about in that consideration, whether you want to take a couple of flights in order to save money, or if you need that direct route for timing, that gets into whole other things, that gets into other considerations, gets really far into the weeds there, but with this, we can at least make sure that we are taking one thing into account. We are being at least a little bit specific to the context of a real-world problem, where the rest of this section is going to be about solving a real-world problem built off of this called the traveling salesperson problem.